games from the System 80 era are already coded. Spider-Man, Black Hole, Haunted House. Man, that's great. Where do you guys figure this should go? Here is some of the production numbers. And whoa, back up. Hold on a second here, guys. Here are the production numbers for the games from this era. Fast computer. That's an hourglass there. You'll see that what our next planned release date, or release of code is, probably Devil's Dare. 4,000 of those things made. Are there any opinions from the audience about what System 80 games we should be looking at? Very shy crowd today. A lot of feedback. Spirit. 1,200 games? Oh man. Yeah, that's the other thing. The reason that we put together the development environment here is that it's very unlikely that I will have every game made. Somebody's going to, and it's going to be that person who has that game who can do that coding. You have to have the hardware in front of you to test it. I wrote Spider-Man, for example, in 4 hours in one day. I didn't have a Spider-Man game, and it didn't work anywhere near what Spider-Man should have. I had an idea what was going on. I had put the logic in, but it took me probably another 8 hours to troubleshoot the code that I just finished in 4 hours. So you can get the idea of what it is that the effort is that's going to be involved. What I do want to begin, before I go too much further, if there's anybody here who can sit back and say, I really think you have to do Striker. I'm not going to do Striker. I'll try something else. A Devil's Dare or Counterforce. I'll take that with me and I'll go back and I'll look to find that game. I bought Panthera today. That might be the 4th game. I've got Devil's Dare at home. When I pick it up, that'll probably be the 5th game. I've got a bunch of System 80B games, but I don't think I'll be doing that for a while. Anyway, you can also send me email, ace@neewamp.com. Send me, the idea of why or what it is you want to see done, and we'll look at that. Again, the hardware is going to be the imposing factor, whether I have it or not, to write the code or not. If you get to the point of saying, well, I'll do it for you, great, then we really do have to talk. Because the development environment is fun. But, like anything else, it takes some ramp-up time to learn, and I'd be glad to help speed that ramp-up time. Writing these games is pretty straightforward. The logic is pretty straightforward. There's one thing that is not easy. Taking an original working CPU board and figuring out what sounds are being developed, what sounds are being output to make what's happening in the game come alive. For example, you can probably sit there with our computer here and send out the sounds, play sound number 1, and you can probably make a note saying sound number 1 sounds kind of like a siren. And then when you think you've got to use that for this switch over here, well, it sounds like a siren. Oh, that's sound number 1. I'll use that. But there are, of course, 16 sounds, and some of them sound pretty similar. And then there are those sounds on the System 80 game that if you strobe the sound pulse more than once, it makes a different sound. So it starts off going wee, and then you hit it twice within 10 milliseconds, it goes wee, and when, how do I find that? This is how you find that. You take your original CPU, you press a target, and this little LED here, which is a 7-segment display, will tell you what sound number was issued by the original CPU to the sound card to play that sound. Now normally on the Haunted House, Black Hole, the early area games, there are background sounds. So each target actually sends from the CPU down to the sound card 2 sounds. One is the background noise, and one is the actual sound itself. So this does display up to 16 numbers as they come down. So if there are 3 numbers being issued to the flash, the first number, second number, third number, fourth number, and it'll cycle back around through. So you get an idea of when that target was hit, 3 sounds came out. That's all you need to do. And then you go back and you say, okay, I can program that into the game development environment. Just go back here and that was sound number, what did I call that thing? I don't know. Sound number, hello. So here it is, sound of attic fuck. Vertical up keeper, by the way. I wasn't mistyping these things. Or the bumpers, so I can tell these are bumpers. Now, what you'll see here is when I do program this, let me see one of these spot targets here. You'll see a little call there, call level change. What this means is change the background sound. There are 3 different background sounds in the haunted house, so when I go to the attic, each time I hit a target in the attic, it goes and says, go tell me to play the background sound for that particular level, and that's what that does. Then of course it tells you if you dropped that target, play that sound, attic target there. So without this sound card, it'd be hard to figure out what numbers are being sent out. This is the next diagnostic tool to basically write game code. If you get to the point that you want to write game code, I'll give you one of these things, and this will help you do that. What have I missed? System 80 release for the UBQ hardware and software environment. We're going to go slow. I mean, it took me 2 years to get to the point where I thought I could handle Surface Mount. We're not going that slow, but I mean, we're going to go slow in terms of I don't know what's coming next. I've talked to Dave and Thad of the Ultimate CPU fame, and I told them I'm going to make a CPU card for Bally-30 boards. You okay with that? Well, no, don't do that. I said, well, it's going to be different. It's going to be a CPU card for which there is source code available. So, and of course, that source code is not going to be instantly available. There's going to be someone who's a big 8-ball deluxe fan, and they're going to say, I want to do the code for that. And it's going to be 1, 2, 3, games per year. It depends on how fast it catches on. But, so there's going to be a ramp up in terms of what platforms are hit, and what code gets released. We're going to do System 80. When I get comfortable with people who are developing the code and they tell me, you got to change this, and when I get to the point where I'm comfortable with the IDE, and I took it off there, being a tool that people can use, then I'm going to go to the next piece of hardware. I mean, it's easy, again, like I said, I can write a game in about 12 hours and be done with a System 80 game. I can't really expect people to write that quickly, and I can't expect to have all the games, but I can expect at some point there's going to be 2 or 3 guys out there that have a lot of games that do like to write code. So I'm going to be making boards for these guys, and they're going to tell me I want to do ballots or I want to do game plans. I think actually I'll probably pull up the value to the game plan, but that's a different story. So what will happen is the hardware is going to get released System 80 first, and maybe Bally's, and maybe Williams, a whole bunch of driver chips on it. But likely to be game plan, Allied V's, or some of the hardware that there is no way to replace the CPUs on now. That'll be the release date, and we'll look for feedback from that again, from you guys, from news groups telling us what is the hardware we should be looking at next. The whole spiel in terms of what we're doing, I'll give you an idea of what it takes to get this stuff done. I gave you an idea why we made things the way they are, and I've given you an idea of the level of difficulty it is to create a CPU for a particular game. What we get out of this, ultimately in 110, I don't know how many years, is we've got software, not hardware. None of this hardware makes any difference at all. We've got software, source code for all the games that are out there in that auditorium being played right now. At least all the games from the 70s and the 80s. And we know that as we go forward, we'll get hardware made for those games. But more importantly, we know something else. If you want to tweak the code to do something specific, you want it to do, like, I really hate Blackwater 100 game runs. Start off low 3 balls, and start off every game, every ball starts up in multi-ball mode. Alright, now I've got a CPU where I can change that design. If I take Mark Clayton's soundboard and I plug this into the system, I'm going to put in new sounds, so I can have my kid making sounds on my CPU board and control it by this system here. I think I've gotten to the point, I believe we are, to it takes about 12 hours to do one game. That's me, I've done it before, so it's going to be easy. For you guys, it's going to take a week to get through the game code to the point where you can, oh, there it is, that's the screen I was looking for, got it. A lot of what's in the software is already done for you. So if you start to program games, what you'll wind up with from our site is a blank template that's going to be one of two, a multi-ball template or a single ball template. And what that means is that when you start with it, it's going to have all the controls necessary to do scoring, displays, firing solenoids, whatever. When the ball drops into the out hole, you really don't have to do anything as long as you have the right template, 1 ball or 3 ball. The game code, the platform code, has already been written. So all you have to worry about when you go code things is there's a switch here, it lights up this light here, sets this variable over here, and I'm done. And then I'll test it, see what happens. When the ball drops in the out hole, my code is already written for you, takes care of, well, now he's on player 1, he must be going to player 2 because we're in a 2-player game. You don't have to do that. You don't have to do scoring. All you have to do is when you do want to score something, I'll handle all the outputs to displays. You would just put in score 3,000 points or score bonus. Here is add bonus. All you've got to do is say, as long as I got the template in place, call the existing routines there. Now there is a little more to it. If you've ever programmed IO21 and MS-DOS back in the 80s, you know there are things called hooks. The game has to be able of predicting what you're going to do in the future. So there are hooks placed in there saying, well, in case you want to do something funky at the end of the ball, there's a hook that you can write code for that gets called by the platform. So at the end of, even though I control all of the, I've got software written for the ball going in the out hole, there should be hooks enabling this system to decide at the end of Haunted House, on the first ball, reset this bank over here. So you can write that routine in there. If you don't write it, it doesn't matter to the game. It's a blank routine. It calls it, and there's nothing happening. It returns back in. So there are hook routines that you can. That's a little more detail than we should be getting into. Any questions, by the way? As you look at this, this is no language. This is my language. If you look at, for example, what you're seeing over here. It's understandable as C or Pascal or whatever, if, then, else, call a subroutine. So you can call any of these routines from a call statement. You can do compound comparisons like this, call it a sound. The language basically was meant to do, it's a pinball language, it's meant to do specifically pinball items like call a sound, call a solenoid, light a lamp. But what happens in the back end of the system, and this is all written in Java, the IDE, at the back end of it, this file gets saved as XML. That's the language if you want one. This XML file gets sent off to N1. N1 takes the code, rips it out, says, okay, I'm going to, sorry, I can't get on the website. I can show you what it basically interprets this language into C, links to C with the hardware API, and creates a binary image from that. So it's kind of C. Anything else? Oh no, Mark. How do you determine if all the targets are down the bank? Good one. Well, here it is. First thing I'm going to do when I create a new game is for my for my targets up there, I'm going to say I've got this drop target right here, and we that variable. I create variables. So when you're writing a game, you create variables, and with this variable is a simple boolean. It says the drop target is down or it's up, and that is your variable right there. The drop target number 1 is up or it's down, true or false. Now what happens in this creation of the variable is you get to tell it when the variable is initialized. And this is, as you can see over on the right there, this is a ball variable. At the end of each ball, the game gets initialized to the initial value of false. So when the ball, you don't do anything after that. You know that the game is going to send the bank back up, and the game has already set all of those drop targets values back to false. It's not one of those targets are down. Now what we do at the other end of this is we say, hey, and a drop scoring now. Is that what I want? Attic bank. What the hell is that? Attic bank complete. There's your variable there, the first one. If the attic drop target 1 is true, and 2, and 3, and 4, then do the following. Check out, has this guy earned any extra balls already? Because when you get to the attic drop target up there, you get a free ball if the free ball is lit. So first of all, it checks and says, has he already earned a free ball? If not, then I can give him one. If he has, this is one of the tweaks you'll find out when you start writing code. Oh shit, I forgot that you can only get 1 free ball during 1 ball, so you got to put in these variables in here. I check to make sure he's only got 1 so far. Yeah, he was the German guy. He said, you know, I've got System 1 games on location, and you are giving free balls, more than 1 for each ball. That's not right. So I had to change all the code and say, okay, set a variable that if he's already got a free ball, he can't have 2. Although I kind of like the fact that you can earn a bunch of free balls. Then, of course, you know, do the rest of this. Assign means, okay, if he hasn't got a free ball already, let the game know that he can get one. Turn on the extra ball light, and you're done. Now, one thing that has to happen is that somewhere in his code, I've got to set that to above 0. So when the free ball is actually scored, you set it to 1, and that variable is a system variable. And that means that when the ball drains out the out hole, it checks for that variable to be 0. You don't have to do any of this. It checks for that variable to be 0 and says, okay, he's got a free ball. It's not over yet. Turn on, well, the light's already flashing, but turn it off when he hits the next target. So that's part of that. Any other questions? Wish I could demonstrate a code compiled for you, but we don't have the internet. I'd be glad to go through some of the hardware diagnostics. I'd be glad to go through some of what the game has in itself for diagnostics. I didn't go through some of the alphanumerics on displays. We try to do our best with 7-segment displays, and you can get pretty much the same hardware menu as you see on the System 1 game we've got now. It's going to be changed a little bit. There's an RBC sounds. It's going to be changed in that now, because you control how to write this software, there's going to be a section here saying what game mode do I want to play. If you've got 2 different ways you want to program Hard-Ass, you can put it all in there and say if the game mode is set to be 1, then do this way. If the game mode is set to be 2, then do something else. And then in the hardware menu here, you can set the game mode to be whatever you want it to be. It's very much like the Williams option settings. Make it hard, make it easy. So that part will be controlled by the hardware menu here. Anything else? Those programmers who want to learn more, come on up. And everyone else, thanks very much for listening. And if you need a System 80 board, we will be able to sell you one by June. I'm still waiting for 100. Very odd. I'm sorry.
What is your website?
www.niwump, that's spelled Ni-WUMPF.com. Excellent. Thanks, Josh. I'm not exactly a marketing wizard. Anything else, Josh? Excellent. All right. Now I'm going to start going into, if you guys want to hear some tech shit, stand up and let's play with the game. I'm turning this off.
It's just an game code that I made to create the whole code. It should be pretty much logical. By logical, I mean when you create a variable, that variable gets sent into this window here. There are 4 types of variables. Variables that get stored in NVRAM. When the game is over, those variables are actually flashed to memory. So you can create variables that are perpetual. High score, for example, is one of those variables. Not just a system variable, you can add your own. In this game here, do I have anything yet? I don't think I need anything. In this one here, I basically had some of the information about name, the mode I was talking to you about, etc. So those variables are stored in NVRAM at the end of the game. If they change, they get saved. The next set of variables are power-up variables. Now these variables only get initialized at power-up. So when you create a variable, you think to yourself, it's going to go back down to the rules and say between games, you know, the following 3 lights are lit, you get a 7. And take 4 or 5 games, you get a free ball. So you're probably seeing that. That would be a power-up variable. When the game comes up, starts at whatever the value it is, you can find one here. as the game progresses through, it can change. It does not get reset at the end of the game. Not get reset at the end of the game or the end of the ball. Then there, of course, are going to be variables such as each ball drains, what should be reinitialized. The idea behind these 4 types of variables is you shouldn't have to go through and write a lot of code. You create the variables in a particular area, the game will keep track of when they should be initialized. That's the first thing. I don't want, again, if you're not a programmer, it's hard to get all this stuff in your mind. I forgot to reinitialize that. The game should be able to, I need to do that. All right, so you create some variables. Out of there, please. You created also some of these matrices, so you know what targets are called what, you know what sounds mean what. And that's kind of the hard part there, is getting just translated tables from the manual into the game. Once you get that done, so I think I can do this. This is a 500 megahertz computer. Do not complain when it's slow. I want to create, let's see if I can do this. System making a template. It's going to take about 3 minutes to load up, so it's just because of the computer. Generic routines like a Nepal routine. Extra ball routine. So with the ball, you score an extra ball, that routine actually exists, predefined. You may want to add to it. So what you do is you add in on it. Not a lot of routines, but it's enough to get to the point of when the game powers down, comes back up again, it's just sit there, blank. Nothing's going to happen. Hold on. Or up alternating display routines. In other words, when you first power up, it'll show you the last 4 scores in the last game. They'll alternate between those scores and the high score. That part will be in there. The rest, it's going to be pretty much something you start tinkering with. Now the lights are all out. You'll go through and you'll start saying things like, I can't show you. You put in the tables, and you start saying, okay, make your variables. Start up with the bank up here. Like Mark asked before, each of these drop targets, you're going to have to know it's up or down. So when it gets hit, set the variable to true. So first thing I'm going to do is create 4 variables for that. Next thing we're going to do is there's 5 bank target down there. Create the 5 variables for that. And I'm going to have things like lit. Spot targets are variables for whether they're lit or not. You'll get creating as you start programming. Variables will become very easy to understand why you need them. It's easy enough to say, oh, that's switch number 1, drop target number 1, went down, set that to true. What else do I have to do? Well, I've got to make a routine. Each drop target as it goes down should call. And that routine should say, are all the drop targets down? What do I do when that happens? And we're halfway there. So that'll be a routine. So that's the next thing you'll start writing, is what happens when all those targets are down. Now, I'm going to try and get to the point of saying some code. So yeah, as you go through it, of how to separate subroutines. Okay, there is, for example, a template game. I give you routines like the following. As the game first starts up, it's going to call animation hook as part of the platform that you're playing. If you haven't written anything for an animation routine, you're not going to see much. What I put in there is kind of a generic, because all the system games have a generic animation routine at the beginning. I left that in here. That generic animation routine basically goes in cycles from lamp number 12 to 41. Lights them all up in sequence. Left that in there. Go in there, tinker with it, do whatever you have to make the animation routine be what you want to do. Now what happens, as you see here, as the game starts up, this routine is called, and again, I'll have a whole manual written that says when routines are called and why. Why does this routine exist? In other words, it doesn't say. This routine gets called by the platform as it powers up, and this routine basically says, turn on, and I've got way past me. Okay, I missed one thing I want to tell you guys. We talked about variables. We talked about the fact that you can create subroutines. Here's a subroutine. I want to make a new one. It is not going to be called any new. Any new subroutine. Guys, look at this. Look. And here is that routine. There's nothing in it. I'm going to start adding things like, this was supposed to be a check for the banks. If the first bank is down, that was a bad move. That was not a bullion. Here's the first example. As you enter in an if statement, what I put in was actually an integer value. Immediately, I can't use any Boolean comparison. So this routine really constrains you in terms of what kind of mistakes you can make. It'd be kind of stupid to compare an integer to a Boolean. It won't let you. It will say if that integer is greater than another integer, you can do something. You can't compare it to a Boolean, you can't compare it to a string. It won't let you. So it does all of the logic behind trying to remove errors. It would be hard to make a compilation error with this system. It can happen. I've done it many times. It happens by copying sections of code from one game, like Black Hole, into Haunted House. When you do that, the variables that are in that routine are copied as well, but they are not created in Haunted House. So it'll try and reference a variable that exists in Black Hole without Haunted House. If you're not doing that, you can't really screw up the IDE. If you're not swapping code between two different games you're developing, you will not find a problem. And when you do find a problem, it will show up in this file here. I can't click on this, we're offline. That will tell you what happens when your code was tried to be compiled. It'll give you the results. And it'll come out and it'll say, just like your C compiler, ball in play, undefined. And you'll have an idea, and it'll tell you the routine, just like a C compiler. So it gives you some idea where to go to. You won't see errors unless you start getting a lot more into cutting and pasting code. The constraints are just too enormous. Alright, so I can't enter in literals. I enter in you. I can do something stupid like this. That would create an error. I should be, I haven't finished that part of the idea. I do not check at this time what you've entered in to make sure it's an integer. This will create an error. The compiler will come back and say, that's a string. You tried to compare an integer to a string. Not a really good idea. You will see you can create some mistakes. That's because I haven't finished some of the areas that occurred. What else? Timers. This is an operating system. What I did before I started making CPU boards was I wrote operating systems for supercomputers. On this is a microchip which handles all the RS-232